This is section 3.6, and it has to do with mathematical models and building functions. So it's in some application problems from the things you've learned in this chapter. Let's look at example 1. It says, let P equal the point xy, which is a point on the graph of y equals x squared minus 1. And then we have some questions. So let's first look at the graph, okay? If we have the graph y equals x squared minus 1, from the last section you know that the parent function is y equals x squared, and it's a vertical shift down 1. So it looks like this. We know this is the origin, 0, 0. And we have some point P that we're going to call xy. We also know that y is equal to x squared minus 1. Okay, that's all the things we know so far. So example 1a says, express the distance d from P to the origin O as a function of x. Now that sounds all crazy and scary at first, but all we want to know is what is this distance from P to the origin. Well, we have a formula for distance. We know it's d equals the square root of the whole thing. I'm not going to recite the whole thing, okay? So what we're going to do is we're going to use our 2 points. We have x and y. That's going to be our x1, y1, and then our second point is 0, 0. That's x2, y2. Those are the 2 points we're talking about. And I'm just going to fill in. So x1 minus x2 squared plus y1 minus y2 squared, or vice versa. It doesn't matter. It comes out the same. So when you do that, you get the square root of x squared plus y squared. Okay? But the direction said to do it as a function of x. So what we want to know is, what would this look like if there were only x's in it? So I have to take out this y, and what am I going to put in its place? I'm going to put what it's equal to, x squared minus 1. So I would have d equals the square root of, there's my x squared, plus take out the y, put in what it's equal to, substitute in, and then that's squared. Now let's simplify that. That would be the square root of x squared, FOIL this out, don't try to do anything cute, okay, plus x to the 4th minus 2x squared plus 1. If you don't believe me, FOIL it out. Simplify that, and what we have is the square root of x to the 4th, and x squared minus 2x squared is, oops, that's supposed to be a 4, sorry, minus x squared, and then plus a 1, and that's equal to distance, and we did it. The square root of x to the 4th minus x squared plus 1. So it wasn't really as bad as it looks. Alright, let's look at part B. It says, what is d if x is 0? Well, here's our formula for d. We have the square root of x to the 4th minus x squared plus 1. So now we want to know, what is d of 0? That would be the square root of 0 to the 4th minus 0 squared plus 1, which is the square root of 1. So d of 0 is 1. Then it says, what is d if x is 1? Again, we're just going to substitute in. In part C, we're going to say d is equal to, or whoops, d of 1 is equal to 1 to the 4th minus 1 squared plus 1. So d of 1 is equal to 1 minus 1 is 0 plus 1 square root of 1, which is just 1. So d of 1 is also 1. And then it says, what is d if x is radical 2 over 2? That's part D. d of radical 2 over 2, again, substitute in, it's the square root of radical 2 over 2 to the 4th minus radical 2 over 2 squared plus 1. Okay, so if you multiply radical 2 over 2 times itself 4 times, what you're going to end up getting is 4/16, okay, because it's going to be radical 2 over 2 times radical 2 over 2 times radical 2 over 2 times radical 2 over 2, 2 times 2 times 2 times 2, 16. This makes 2. This makes 2. 2 times 2 is 4. All right? Minus 2/4 plus 1, which is, if you simplify, square root of 1/4 minus 1/2 plus 1, or square root of 3/4, which is d of radical 2 over 2 is equal to radical 3 over 2. All right, so that's all we've done on that problem. Then it says, using your graphing calculator, graph the function d equals d of x for x greater than or equal to 0, and find the values of x at which it has a local min. So what you're going to do is to put that into your calculator. Now notice, I only drew quadrant 1. Why? Because it says x is greater than or equal to 0, so I can't have any negative x's. And since d of x is a square root, I can't have any negative d's either. So when you graph this, this is going to be very not accurate. All right, you're going to get this local min here when you pop the equation in. When I say the equation, I'm talking about what we ended up getting. D of x was equal to square root of x to the 4th minus x squared plus 1 when you put that in. And then you can do a trace, or you can do that second calc and pick number 3, which was the local min, and you're going to see the point. 0.71, 0.87. That's what I rounded off, something like that. All right, so that's just an application of some of the things we've been doing. Let's look at example 2. A rectangle has one corner in quadrant 1 on the graph of y equals 25 minus x squared, another at the origin, a third on the positive y-axis, and the fourth on the positive x-axis as shown in the figure below. So let's fill in that information so far. A rectangle has one corner in quadrant 1, but it's on the graph of y equals 25 minus x squared. So that graph of y equals 25x squared, let's see, 1, 2, 3, 4, 5, looks like if you graphed it, it kind of goes like this. So here's this rectangle where we've got, I'm just going to use this, we've got this point, xy, okay? Then when we come back here, it says it has a point on the origin, 0, 0, and then it has a point on the y-axis. So what's that going to be? That's going to be 0, y, and then it has a point on the x-axis, so x, 0, and that forms a rectangle. That we have this rectangle here, right here. All right, so you first have to understand what the setup is. Then it says, A, express the area of the rectangle as a function of x. Well, we know, let's find the length and the width. We're going to call this the length and this the width, okay? So length is the distance between this point and this point. So I'm going to go x1, y1, x2, y2. That's length. And that distance formula is x minus 0 squared plus y, which the same y is a 0, minus 0 squared. Okay, I'm just following the formula. x2 minus x1 squared plus y2 minus y1 squared. I'm just following that formula for this side for length. And when you simplify that, you get square root of x squared plus 0, or the square root of x squared, which is just x. So I know my length is x. I'm going to do the same thing for my width, and I have width equals, if I call this x1 and y1, and this x2 and y2 now, I would have square root of x2 minus x1 squared plus y2 minus y1 squared, or width equals, this is just gone, and we have square root of y squared, which is just y. Okay? So the area is length times width, which is x times y. But it wants you to show that as a function of x. So I got to get rid of that y. Do I have something to substitute in? I certainly do. Right there it is. So what I have is the area equals x times, take out the y, put in 25 minus x squared, and now simplify. 25x minus x cubed. So there I have my area in terms of x. Very simple. All right? That's A. B, it says, what is the domain? Well, x has to be greater than 0, and y has to be greater than 0. So we know that 25 minus x squared, that's what y is equal to, has to be greater than 0. And if I solve that, I have x squared is less than 25. So x, if you take the square root, x has to be between 5 and negative 5. So when we show the domain, we would write it like this. The set of all x such that x is between 0 and 5. Why did we say it that way? Because here it says x has to be between negative 5 and 5, but here we already said x has got to be greater than 0, so we have to discount that and put in that 0 there. A little bit tricky. Okay? C, it says to graph. Now, let's look at what our function is. Our function is a of x equals 25x minus x cubed. I'm going to have you put that in your calculator, but I want to tell you what the window should be. We know that the smallest x we can have is 0. So the x min is 0, and it can go to 5. And then this is x min and max in your calculator. And then the y min and max, we're going to go, and by the way, leave the scale at 1. The y min and max is going to go from 0 to 50 and change the scale to 10. That's how I want you to set up that window. And what you're going to see is something like this. And we want to know what is that max point. That's D. And again, you can do second calc, or you could do a trace. There's several ways you can do that. But what you get is that x is 2.89 and y is 48.11. That's that point right there. So that's pretty simple. All right, example 3. It says a right triangle has one vertex on the graph at xy, another at the origin, and the third on the positive y-axis. Well, let's first get it set up. All right, again, that's the key to these kind of problems, is understanding what it's telling you. So you got a right triangle. It has a vertex on the graph of y equals x cubed. That's one of our parent functions. So it goes like this. So we're going to say here's that point. We're going to call that xy. And then it has one at the origin. That's the point 0, 0. And it has a third at the y-axis, 0y. So here is our right triangle. You see it? All right. It says express the area of the triangle as a function of x. So here is the area that we are talking about. So what do we know? Area of a triangle is 1/2 base times height. Here's our base, here's our height. And you can see that the height obviously is y. Do the distance formula if you don't believe me. And the base here is x. Again, do the distance formula like we did in the last one if you don't believe me. The distance from here to here is x. The distance from here to here is y. Okay? So what we have is that area equals 1/2 times x times y, or you could say xy over 2. But we want to do it as a function of x. So we would say a as a function of x is equal to x, take out the y, and put in the x cubed times x cubed over 2, or a of x equals x to the 4th over 2. That was an easy one. That's an easy one. Alright, for homework, I want you to do problems 1 through 17, the odds.